to the Geomastic channel. In this lesson, we'll cover the standard form equation of a line, including how to write an equation in standard form, how to graph it, and how to convert it to and from other forms. If you like taking notes, click down on the link in the description and print off a guided notes worksheet that follows along with this video. You can write some things down and follow along. Now the standard form equation of a line, which looks like this, you've got A, color coded here, Ax plus B y equals C, where A, B, and C are integers. And integers are just positive, negative, whole numbers. Now, depending on your text or your resources or your teacher, it might say that A, B, C are real numbers, or that A and B have to be non-zero integers, or that A must be positive, or that C can't be zero. There's lots of different qualifiers here depending on the text that you use. So my recommendation would be to check with your teacher, check with your textbook, and see what it says about A, B, and C. In today's lesson, we're just going to say A, B, and C are integers. So again, just positive, negative, whole numbers with zero. Now, I'll admit that when it comes to the equation itself, standard form probably looks the nicest out of all your options for forms for the equation of a line. So we're talking about slope-intercept form, which was y equals mx plus b. A lot of times in a form, in slope-intercept form, your m might be a fraction, so you might be looking at something like this. And then point-slope form, which looks like this. Sometimes that can seem a little bit confusing. So again, as far as how it looks, standard form probably looks the best, but I would argue that it's kind of the clunkiest as far as its ease of use. A lot of times the problems that you'll have when you're using standard form is to get it out of standard form to get what you need. So the good news though is that you're only a couple of steps algebraically away from anything that you might need in standard form. But there are a few things that you can do with a line that is in standard form without converting it to any of the other forms. And one of those things that you can do in standard form is you can graph a line if it is in standard form. So that's what we're going to do first. I'm going to graph out here. So let's say we have a line in standard form. I'm going to write, say, 6x minus 3y equals 12. Okay, so we got 6, 3, and 12 are A, B, and C values. You can see that they are integers. Let's say we want to graph this line. Okay, so when we're graphing a line, really all we need is 2 points. Once we have 2 points, we can graph a line. What we're going to do in this case is we're going to graph this line using its intercepts. So by intercepts, I mean where the line crosses the y-axis and where the line crosses the x-axis. So to do this, we're going to think about 2 points on this line, and the 2 points that are probably best or easiest to find are the x and the y-intercept. So if I look at the x-intercept, so where the line crosses the x-axis, think about what is the y value for any point on the x-axis. Okay, so my y value, my up and down, north, south, anywhere on the x-axis, the y value is going to be 0. So my x-intercept is the point where the y-coordinate is going to be 0. Same thing for the y-intercept. If I'm looking for the y-intercept, anywhere on the y-axis, what is the x-coordinate? Because I'm not moving left or right, anywhere on the y-axis, the x-coordinate is going to be 0. Okay, so what I want to do is I want to take this equation, this standard form equation of this line, and I want to find where those two intercepts are, the x-intercept and y-intercept. Okay, to do that, because I already have half of my point, I'm going to plug in a 0 for, in this case to find the x-intercept, I'm going to plug in a 0 for my y. So if my y-coordinate is 0, this equation becomes 6x minus 3y, where y is 0, so I'm going to plug in a 0 there, equals 12. Okay, so 6x minus 3 times 0 equals 12. Now 3, or minus 3, times 0 is just 0. So I've got 6x minus 0, or just 6x equals 12. And if 6x equals 12, what would x have to be? I would divide both sides by 6, and 12 divided by 6 is 2. So when the y value is 0, the x value is 2. And that is the x-intercept of this line. So I can go over here to my graph, and I can plot that point to 0, which is right there. Okay, I only need one more point to get this line. The point I'm going to get is that y-intercept. So same idea, in this case the y-intercept is where the x value is going to be 0. So I'm going to kind of do the same thing, and I'm going to plug in a 0 for x. So I would have 6 times 0 minus 3 times y equals 12. So again, the 6 times 0 really just is gone. 0 minus 3y is just negative 3y. So negative 3y equals 12. I would divide both sides by negative 3. And 12 divided by negative 3, that's going to be negative 4. So my y-intercept for this line is going to be 0, negative 4, which is 1, 2, 3, 4 down, right there. Okay, so once I have 2 points on that line, I'm really just going to connect the dots here, and that would be the graph of the line 6x minus 3y equals 12. Okay, so this is called graphing using the intercepts. And if you're comfortable with the algebra there, it's just really just 2 steps. If you kind of cancel out those zeros that go there, you're really just dividing by the coefficient in front of each of those variables. Okay, so in standard form, you can graph fairly quickly. Another option, which I'm not going to do, but we'll kind of talk about in a second. If you want to graph a line that's in standard form and you're comfortable with slope-intercept form, you can just solve that equation for y, get the y by itself, and you can graph in slope-intercept form. Okay, so the next example I'm going to do, I'm not going to graph, but I'm going to show you just a conversion. We're going to convert to slope-intercept form. Especially because slope-intercept form is the form that you probably learned first and you're probably most comfortable with. There is a benefit to knowing how to get a line that is in standard form to convert it into slope-intercept form. So let's say we have 2x plus 6y equals negative 6. So this is in standard form. Again, standard form, you have your 2 variables on the left side, you have your constant on the right. And let's say that we want to take this line in standard form, we want to put it in slope-intercept form. So we got y equals mx plus b, that's your slope-intercept form. And the goal here is to get that y value by itself. Okay, so this is just a couple of steps. We're going to use some algebra, we're going to get that y by itself. So the first thing we're going to do is we're going to move the x variable, we're going to move that to the other side of the equation. To do so, we've got a 2x here. To get rid of a 2x, we're going to subtract 2x from both sides of this equation. So there's my equal sign, so I'm subtracting it from the left, subtracting it from the right. 2x minus 2x is 0, so that's gone. So on the left, we've got 6y equals. On the right side of the equal sign, we've got negative 6 minus 2x. Because those are not like terms, don't be tempted to try to put those together. This has an x and this doesn't, so I'm just going to rewrite this. Usually in slope-intercept form, we're going to have our x, our variable term is going to be first. So I'm going to write this as negative 2x minus 6. Last step, to get the y by itself, I've got this coefficient, the 6 right here. I'm going to divide everything by 6 to get rid of that 6. So I'm dividing everything by 6. 6 over 6 is just 1, or 1y. I've got negative 2 over 6x, and then negative 6 over 6. Go ahead and divide that. Negative 6 divided by 6 would just be negative 1. So I've got y equals negative 2 over 6x minus 1. And the last thing I'm going to do is I'm going to go ahead and reduce that fraction, that slope there, which is negative 2 over 6. That'll reduce, I can divide both by 2 to negative 1/3. So I've got y equals negative 1/3 x minus 1. So these two lines, 2x plus 6y equals negative 6, and y equals negative 1/3 x minus 1. If I were to graph those two, it would be the exact same line. It's just different forms. So I've converted from one form to another. Now I can also do the opposite. I can take a line that's in slope-intercept form and convert it into standard, and it would basically just be the opposite steps. I would move the x term to the other side of the equal sign. I would multiply everything by 3, in this case, the denominator of that slope, to get everything in integer form for my a, b, and c values. But I can go backwards as well. So forwards and backwards, it's just a little bit of algebra. Okay, one more example here. Another thing you might see is to write an equation in standard form if you're given certain information. So this last one, let's say we want to write the equation of a line that goes through the point 6, 1. So I want that to be a point on the line. And I want my line to have a slope of 1/2. So I'm writing the equation of a line that goes through the point 6, 1 has a slope of 1/2. Now, unfortunately, there's no real quick way to go from information like this to standard form. I'm going to have an intermediate step in between. And the best way to write the equation of a line if I'm given a point and a slope is that point slope form. So again, point slope form, y minus y1 equals m times x minus x1, where x1 and y1 are the coordinates of the point, and m is the slope that we're given. So if you talked about point slope form, it should be pretty quick. If you haven't done a video, you can find that right up there to review point slope form. But really, point slope form is pretty quick. So it looks like this: y minus the y coordinate of the point, which is 1, equals m, which is the slope, 1/2, and then parentheses x minus x1, which is the x coordinate of the point, that is 6. Okay, so we've got the equation of this line in point slope form already. And now if we want to go from point slope form to standard form, we're going to do those steps that I just talked about. Do a little bit of algebra here. First thing I'm going to do is I'm going to distribute out that half. So I've got the parentheses there. Distribute the half to both terms here. So I've got y minus 1 equals half times x is half x. Half times -6, that would be -3. Next step here, I'm going to add this 1 to the other side, which will leave me with y equals 1/2 x. -3 plus 1 is -2. So at this point I'm actually in slope-intercept form. But if I want to get to standard form, we got to get all the variables to the left, get the constant on the right. So in this case, I'm going to subtract the half x from both sides, which will get rid of it here. Move up here. So I've got -half x, -half x plus y equals -2. And then last step, because again, with standard form I want these coefficients to be integers, I've got this -half. I'm going to go ahead and multiply everything by the denominator of that fraction, which is 2. Now again, if you like your x or your a value to be a positive integer, you can multiply everything by -2. In this case, I'm just going to say integers are fine, so I'm going to multiply everything by 2. So everything's going to get multiplied by 2. 2 times -half would be -1x, or just -x. 2 times y would be 2y. And then -2 times 2 would be -4. Okay, so there would be the equation of that line in standard form. So you can see it does take a little bit of process here to get from this information to standard form, and you kind of have to get through the other two forms of an equation of a line to get to what you need there. So that's why I say it's a little bit clunkier than the other two forms, but depending on what you're doing, could be the best way to go. A lot of times it's getting out of standard form that is what you're going to have to do. So I hope this helps you navigate the standard form equation of a line a little bit easier. If it did, give the video a thumbs up and subscribe to the Geomistic channel to see more videos like this one. Thank you for watching, and we'll see you next time.